All right. So back to where we were before. In the last part of this discussion, we were talking about kin selection and eusociality, and how kin selection is part of is a factor in eusociality. And we're talking about diploid relationships, in which the mother had 2 chromosomes and the father had 2 chromosomes. The father would pass 50% of his genes to the offspring, leading to a 50% gene frequency. And the mother passes half of her genes and her chromosomes to the offspring for 50%. And the siblings also share 50% gene equality. This is because of recombination. So now I'm going to talk about diploid-haploid relationships. And this is really common in Hymenoptera. So in this relationship, the mother has 2 chromosomes. But the father only has 1. The mother insect lays eggs, but if that egg is not fertilized, it becomes a male. And if it is fertilized, it becomes a female. So let me draw our chromosomes first. So the mother has 2 chromosomes, and the father has 1. All right, so if it's fertilized, and you produce the boy, he's only going to get 2 chromosomes from his mother, but he's not going to get any chromosomes from his father because it's not fertilized. So he doesn't have a father. He only has a mother. So let's say this is the chromosome of the son. Now let's say the father mates with the mother. Then there's genetic recombination, and the daughter will get 2 chromosomes. All right, and both of these have recombination, but this one has recombination between the mother and the father, and this one has recombination between only the mother. All right, so what we need to look at in a haploid-diploid relationship is first, we have to notice that 100% of the genes from the son comes from the mother. All right. But if we look at, say there are 2 different brothers, right? We may notice that another brother has a chromosome like this. Therefore, brother-brother relationship is only 50%. Because it has some recombination of this, of the 2 chromosomes that the mother has. However, with a sister, you have recombination between both of them. And this is where it gets interesting. Between 2 sisters, you will have 25% shared genes from the mother, plus 50% shared genes from the 1 chromosome from the father. And this leads to a sister-sister relationship of 75% shared genes. All right. The next thing I'm going to talk about is evolution of altruism and eusociality. All right, 5 minutes. All right. And what we notice here is that there's a specific formula in which we can define altruism as. And that formula is RB is greater than C. All right? So C here is the cost to the altruistic insect. And B is the benefit of the recipient. Where R is the genetic relationship or relatedness of the two insects. So if RB is greater than C, that's when you get altruism. The next topic we will talk about will be repeated evolution of sociality in insects. This is most common in bees or Hymenoptera. All right, and it's believed to have evolved 9 times. And this is due to diploid haploid effect, nest making, and morphology. All right. And it's also believed that there are 16 insects involved, as we know it, in repeated evolution of eusociality. Another one would be ants, specid wasps, vespid wasp, thrips, aphids, termites, and beetles. And these are the 16 insects believed to have evolved repeated evolution of sociology. Alright? So for the third part, I am going to discuss about the benefits of sociology and nest making. And if I have time, I will also go into social parasitism